Everyone, it's a pleasure to be here in Berlin, speaking in front of this amazing community. And today I will talk about optimizing the startup times in React Native. And the presentation will be heavily focused on the mobile development, as we'll be diving deep into what's happening on our mobile devices. However, there are some generic concepts that you can reuse across the platforms. So I believe everyone will find something of interest. But first, let me introduce myself. I'm Michał, and I'm an independent consultant on React Native. And I assist various companies in optimizing their app performance, building connections between the native apps and React Native modules, and auditing the project architecture and development practices. Additionally, I'm an open source enthusiast, and I maintain some core React Native modules in the open source community. So without further ado, let's dive into the anatomy of application startup. So we need to begin by asking ourselves a question: what is an app startup? And does this process always look the same? Or are there different kinds of application startups? So we can begin with the most common case, which is tapping an app icon. So for now, we can just assume that this action starts the app from the ground up. And it means that there's no existing process related to the given application. And we render everything from the scratch. And soon we'll discover that it's often not as simple as it seems. But for now, we start with nothing, we tap, and soon we have the app fully running. Now let's consider the opposite case. So we go to the app picker and choose an app from the list. Hopefully the one that was already running. And we consider that a startup as well. Again, this is a bit of simplification, but for now, let's just remember that the app was running in the background and it did transition to the foreground. Thus, the startup happened almost immediately. So we'll refer to the first scenario as a cold start, which occurs when an app starts from the scratch. The second one we'll call a hot start, indicating the immediate opening of the app. But is it really a binary phenomenon? I mentioned earlier that it's not as simple, and there are some cases in the middle, commonly referred to as warm starts. So let's look closer at them. So instead of adhering to a binary paradigm, we can think of a startup process as a temperature spectrum. So imagine measuring our app with a thermometer that has a scale from 0 to 100, where 0 represents a cold start and 100 represents a hot start. So this means that our app might be chilly, might be lukewarm, or actually warm. But what does this really mean in practice? So the nature of mobile apps is quite complex, and there are numerous optimizations at the OS level designed to enhance the resource management in our devices. And this essentially means that when your app is in the background, some of its parts can be destroyed to conserve valuable resources. And in such cases, you don't need to build the process from the scratch, since you have some sub-processes running and they are still operational, and you can just reuse them. And on the other hand, operating systems are getting more and more intelligent, and they are very intelligent, in fact. So even if you don't have an app in the background, they might still initiate it, or a part of it, attempting to anticipate your behavior. So for example, if you open your running app every day at 8 a.m., it might happen that iOS will pre-warm your app at 7:50 in order for you to get a better user experience. So things are getting pretty serious, right? Yeah, so now that we know what we are dealing with, let's focus on a detailed view of a startup process in React Native apps. So the first thing that happens after building an app from the scratch is the creation of a process that will handle the app creation. This is when the static libraries are loaded into the memory and all the preparation to create an instance of the app is done. Then it's time to create an actual application. So we built its components, we prepared everything that's necessary to render a UI, perform the first round of renders, and execute our custom initialization code. Another component, which is specific to React Native and absent in React Native apps, is the loading of JavaScript bundle. So we have a file with our JS code, and this is the time when it gets loaded into the memory and evaluated. And this is when your root index.js file is executed and the JS bridge is set up in the old architecture. And another phase of the startup process is the root view rendering. So this is the time between finishing the evaluation of the JS bundle and the first React render. So this is where the RCT root view and React root view are instantiated and rendered, and the first React components come into play. And the final phase, relevant to our considerations, is the actual React app render. So don't be fooled by the size of this block, as it doesn't represent the exact time contribution to the process. And it often happens that this consumes most of the time during our startup, especially if your app is large and performs numerous operations at startup. And obviously, the application startup in React Native can't be too easy, so let's complicate things a bit. Yeah, so not all the components occur in sequence. As you can see on the slide, the loading of JavaScript bundle usually begins when the process of creating a native app is executed. And it also means that these two phases can overlap. But also, it can finish before the native app is created. And the root view can also be created and waiting for an actual render. And once again, things can't be too simple. Yeah, sorry, I jumped the gun a bit. I spent some time in Spain this year, and people here are accustomed to a thing called siesta, and personally, I couldn't adapt to that, but apparently mobile apps can. So it might happen that the process is created hours before before the app is actually created. So the app does some work, it takes a nap in the background, and then finishes the work after a well-deserved break, or whenever you need it. And it's not only that, because as mentioned before, it might happen that the UI part of your app is destroyed when the app is in the background. And this means it has to be recreated next time you access the app. And in such case, the time between starting the process and rendering the app might be really long. It can even exceed a couple of hours. Okay, so with all that information, and given that we now understand what the process looks like, it's time to gather the actual data. So real user monitoring is a broad topic, and there are many tools that measure various things for us. And these tools often provide KPIs without a detailed explanation of each metric. And for example, you might get a cold start metric from service like Firebase or Sentry. And while it's usually fine for regression monitoring, it's often not enough for the optimization. So we'll begin by identifying and marking the key points between each of the startup phases. And by tracking these intervals, we can better understand the duration of each phase and find potential bottlenecks in the process. So let's take a look at each phase once more. So we need to set markers at the beginning and the end of each phase. Sometimes the end of one phase might coincide with the start of another one. And that's usually true, but in case of a top row, if we exclude breaks that I spoke about, it's true. On the bottom row, you can see that I put some extra markers for the things that do happen like asynchronously, and also there's a native launch end marker that will be helpful for validating the consistency of the data. And taking at the closer look, what does it really mean in practice? What these markers are? So the native launch start is captured when the first process is started, and both platforms provide some low-level APIs to read that timestamp. Then we have the process creation end, and on iOS, this is the moment when Objective-C's initialize and close functions are called, and I did not found an equivalent in Swift. That's why you might implement it in a bridged file. But if you find something, let me know. And on Android, it's the creation of the content provider. Application creation is pretty straightforward. Both platforms, iOS and Android, expose popular hooks for that. So on Android, you can simply hook into the application lifecycles. On iOS, you can use the main method or app delegates that finish launching with options. Next, we have the events that are emitted by React Native Core, and they can be used to mark the beginning and the ending of the JavaScript loading. And on iOS, we can use the Global Notification Center, and on Android, simply import React Marker from the core to listen for these events. And the same principle applies to the content appeared marker, but there's no generic place to define screen interactive marker. It's specific to each application, so usually you know best when you consider your app interactive. I often mark this moment as when the splash screen disappears, but that's not always the case. Okay, now that we know where to place our markers, we can measure the time between them. And you can use various tools for that, but I definitely do not recommend operating on the raw date objects and their timestamps, because utilizing precise clocks is a preferable approach. And my favorite library for conducting all these operations is React Native Performance. It's really lightweight, and it implements user timing and performance web APIs, and has built-in support for most native markers that we need. We just need to add a few, but generally it provides a toolset to place some custom markers on both JS and the native side. And after you're done collecting the measurements, simply push them to the analytics system. So if you are working on a large-scale app, you might consider sampling, and this step is in general not mandatory for the process, as you can also use this infrastructure for debugging of the locally created release builds, but obtaining more data insights will provide you with a better overview. And it doesn't really matter which analytics tool you use. It's as simple as sending the data to, with the payload to a given analytics system. So we just match the name for the measurement with its duration and analyze the data. Okay, so we do have all the data now, which means it's just about the time to start the actual analysis. But can we actually proceed at this point? So when you look at the data set that we'll have at this stage, you will find a lot of outliers and inconsistencies. And source of these lies in the nature of the application startup that I described in the first section. So now I will show you how to overcome these challenges. And we need to start by finding a consistent measurement point. Not all the starts are the same. In fact, they vary significantly. And we can't compare apples to oranges, so our measurement point needs to be consistent. So if we consider a spectrum from the first slide, we can get back to it and try to grasp a deterministic point on the scale. So where will it be? Are there any points that will give us consistent results on every device, on every platform? Yeah, so this is the only deterministic point that makes sense. A truly cold start, where we need to perform all the operations required to start the app. And we know that we must do everything, and everything is usually the same on each platform. And I mentioned that it's the only point that makes sense, but it's not the only deterministic point. And there's another one, and I wonder if you can guess where it is. Okay, so it's a purely hot start. However, in this case, there are no startup operations. So we simply transition from the background to foreground, while everything is memory, so t equals 0, so there's nothing to measure. And if you are wondering how to distinguish between cold, warm, and hot starts, feel free to use these code snippets. They are battle tested, and I guarantee they deliver good and consistent results. And on iOS, it's a pretty simple process, while on Android, you need to do much more to distinguish the startup time. In the attached QR code, I also link to the articles explaining these processes in detail for each platform, so I really recommend checking them out. Okay, so now that we know what kind of startup we are dealing with, it's time to address the siestas between the phases. And first, let's consider the case where we perform a foreground start. This means we have all the resources necessary to start the app. And of course, it doesn't mean that every single bit on our device is available for us, but we can assume that we have everything we need. But that's not always the case. So for example, if you have integrations like HealthKit, your app might be started in the background. And unfortunately, in such case, we won't have full resources nor the priority. And we also have no guarantee whether we'll have 40%, 60%, or 10% of available resources. And this heavily impacts the startup time. And there are also cases where user might start the app and put it to the background and put it back to foreground and do whatever with it before it finishes starting. And such cases will also produce indeterministic data and should be excluded from our analysis. Okay, so diving into the code, the distinction between the initial process type is quite straightforward. We check the current app state during this app start on iOS and process importance on Android. And utilizing this approach ensures that our app's functionality aligns seamlessly with the respective operating system's processes. And similarly, we can flag the cases where the app was put into background during the startup process and simply add the flag to the respective application state hooks and use it for further analysis. Whoops, sorry about that. Yeah, subsequently, we'll need to add the flags to our reporting dashboard. And again, this step is optional, but I want to emphasize that gaining insights from production is invaluable. So I recommend adding these flags as extra attributes to your tracking system to facilitate further analysis. Every analytics system that I know supports custom attributes, so it should make no difference which one you choose. Next, we need to focus on filtering the data to obtain a clean sample for our analysis. And the filtering system might be specific to the analytics tool you use. So let me just show you a few generic SQL lines that you can then translate to whatever query language you use. Yeah, so I recommend creating a separate measure for the total startup time, which is simply the time between the first and the last marker. And we should filter the data by flags, platforms, and app version. And then we can calculate percentiles and plot some charts. And we can put it all into a monitoring dashboard that can help you tracking your optimization progress, but also any regressions over the time. And given that we have all the data, we can start the actual optimization. So I will show you a few simple steps that you can apply to your optimization process. But if you are interested in a more robust optimization approach, feel free to visit my website. I have a video about optimization process linked there. And yeah, if you are interested, feel free to visit. And the first step is finding the bottlenecks. And this is where some detailed measurements come in handy. So simply analyze the gathered data, take a look at which part of the process is longer than usually, and take the relevant action. So we can take a quick look at the most common bottlenecks for each phase. And for example, if you experience some slowness during the native process initialization, you might want to look at the native modules and third-party libraries that you use, and they might do some heavy initialization, or they might execute some code that could be executed asynchronously. In case of a problem in app creation, examine the lifecycle hooks and all the operations that you perform there. Most likely there's something slow in one of these functions. Another one to look at is a slow root view rendering. And we rarely see any slowness here, but if you encounter a problem, inspect the top level components render times. And if you identify any issues with lengthy JS bundle evaluation, investigate what's happening when you execute your top-level index.js file. Usually, there are a lot of operations that are done there, so you might need to break down this measure even further. And similarly for the app renders, start by examining your top-level component, the one that's rendered in app.js, on however you call it, the one that you register in the app registry, and inspect the render times of components down the React tree. And again, more detailed breakdown might be necessary. And the next step involves profiling the target area. At this point, we'll need to dive deeper into details of specific phase and understand what's going on under the hood. And there are several profiling tools for both React Native and native apps that I usually use at this stage. And I will just briefly mention a few that I find most useful. So my favorite one that usually helps me the most is Chrome DevTools. So it allows you to inspect what's happening in the JavaScript realm. So here you will see a breakdown of all the JavaScript calls and the respective execution times. However, exercise caution at this point, as abundance of the data might be overwhelming. But with intelligent analysis, you may uncover many insightful findings. Another one is the React Profiler, and it's among the most invaluable tools for React, because this integrated API allows us to gauge the frequency of renders and the time taken to render a component. And such information is crucial when we are optimizing the performance, because in React and React Native apps, performance often suffers from redundant rendering. And while the tool itself is primarily designed for development mode, you can use it in production as well, but you might need a special version of React for that. And for the native development, the go-to method involves utilizing the native profilers integrated into IDEs. So tools like Xcode Instruments and Android Profiler offer extensive capabilities to monitor resource utilization, network traffic, and trace the processes across the threads. And analyzing the data from these tools can provide a lot of valuable insights, and I highly recommend taking your time and getting yourself familiar with these tools. And once you're done with profiling, addressing it's quite straightforward. So in my opinion, like recognizing the problem is the key to resolving it. So sometimes it may be a significant issue, but usually it's something that can be addressed within the couple of days. And I believe the most challenging part is already behind you at this point. And that's all from my side. So if you ever need help optimizing the app startup or anything else related to React or React Native, feel free to reach out to me via my website or any other channel. I will be happy to help. Thank you.
Thank you, Michael. Are there any questions?
Thank you for the talk. I'm curious, how do you handle actual hardware discrepancies when you're looking at something through a dashboard, say compared to like a Samsung Galaxy A21, which has got really, really bad performance compared to a Galaxy S20, whatever it is, the latest one that's got iPhone level performances, especially on Android. Like, how do you make sure your data stays clean? And I guess on top of that as well, how do you account for the resource allocation, which might be different depending on what other apps and processes are running on the device at any time?
Yeah, so I will start from the second one, because that's why I really like to gather as much data as you can, so avoid sampling if possible, because with statistics it all becomes simpler, because you operate on a larger pool of data. Like these cases, these differences are mitigated when you analyze the larger data pool. This is what I usually look at, and I check how it looks for an average user. So what's the median, what's the 90th percentile, so what's the long tail, and try to understand these sessions. So I think also in that case, what's crucial is a good coverage of breadcrumbs and the user behavior tracking, because it allows you to better understand what was happening in certain section and see if there are any patterns that can be repeated. So that's for the second question, and for the first one, I don't have any specific answer. Probably I would just try to understand what exactly is happening on that specific device and why, and if we can do something to mitigate, basically, if it's a common issue for all apps at this device, or is it specific to our device, and try to understand the nature of it, because I don't have any specific answer for that.
Thank you. Any other questions? Okay, you can still ask Michael. He will be around.
Yeah. Thank you a lot.
Thank you.